Hello, ladies and gentlemen of Algebra 2B. This is 8.3, talking about square root functions, inequalities, and kind of graphing and analyzing square root functions, knowing what they look like, knowing what they're going to look like, trying to figure out a domain and range. You are going to want a graphing calculator for this, so I have a graphing calculator handy, or you can use Desmos on your iPad. If you don't have Desmos, I highly recommend downloading it because it will come in very, very handy. Let's take a look. So if we look at the function x squared, all right, everybody in the room should know that x squared is going to look something like this, okay? So let's look at the inverse function. So remember, inverse just means flip x and y and solve it, okay? So square root, so y equals square root of x. Now if I put in the square root of x, you know, I can if I graph this, I'll graph this in red just so you guys can see it. It's going to look something like this, where it's going to go like so. Now notice it's kind of a reflection of x squared, you know, that same kind of idea that it's going to reflect over that perfect diagonal, x equals y. But notice there's no line underneath, okay? I did not put a line underneath here, and I did that for a reason. This only works, square root only works with positive numbers, okay? Down here, down below, you know, that doesn't work. I can't take the square root of a negative number, or I can't get the square root of a, I can't take the square root of a negative, and I will never get a negative answer as a square root. So kind of consider that. So the basic function looks like this. You know, if I get rid of all this stuff, the basic function for just square root of x, this one, is just going to look like this. That's all it is. So everything else is just a variation, moving that around. So if I graph y equals greater than, or the square root of x plus 2, state the domain, range, x and y intercepts. So if I go back and graph this, again, I'm looking at what I'm doing here. So negative 3 plus 2 equals negative 1. Can't do square root of negative 1. Not possible. Negative 2 plus 2. All right, that equals 0. So square root of 0 is going to be 0. Negative 1 plus 2 is going to be 1. Square root of 1 equals 1. 0 plus 2 is square root of 2, which is going to be, you know, 1.41. And you can kind of see how this is starting to go. 1 plus 2 equals 3. Square root of 3 equals 1.71. So if I go to graph this, at negative 3, I'm not on the graph at all. At negative 2, I'm 0. Negative 1, I'm at 1. And I'm going to kind of look like that. So my x-intercept is going to be at negative 2. My y-intercept is going to be between 1 and 2. Okay, my domain is going to be, remember, domain is, what are my limits going left and right? Well, my domain means I got to go x greater than or equal to 2. My range is going to be y greater than or equal to 0, okay? If I look, remember how domain and range works. Domain, left and right, range, up and down. Well, I'm never going this way. I'm stuck here at negative 2, and I'm going that way. So this should actually be negative 2. So I'm stuck in negative 2, and I'm always going that way. For range, remember, range is up and down. Well, I'm never getting down here. I'm always going to be at 0 or above. So that's what I say. So rules to live by. Keep these in mind, a couple things. First off, can't divide by 0. That's a big one. Can't take the square root of a negative number. That's a big one. Negative exponents in simplified answer don't have. No radicals in the denominator. No fractional exponents in the denominator. All right, so no fractions, no negative exponents, and don't divide by a negative number. So, if you're trying to figure out your domain, the part underneath the square root, set that equal to 0. Okay, so 4x plus 2 is greater than or equal to 0. So 4x is greater than or equal to negative 2. So x has got to be greater than or equal to negative 1/2. Notice I didn't switch the sign because I'm not multiplying or dividing by a negative. So here, just this part goes underneath. 2x minus 3 greater than or equal to 0. So 2x greater than or equal to 3. X greater than or equal to 3/2. There is my domain. All right? Range is pretty easy. Range, you're looking at the number after the radical. You're looking at C. If there is no number after the radical, the range is just y greater than or equal to 0. If there is a number, then it's just y greater than that number. All right? So here, C is going to be kind of my big player. So for that same function, you got the domain is greater than or equal to 1/2. The range, since there's no C out here, is just going to be greater than or equal to 0. Here my range is going to be greater than or equal to 4. And I encourage you, take a minute, graph both of those. Look at those things in Desmos or a graphing calculator and see what you got. And kind of, look at the table and kind of see what it looks like and why it should make sense to you. So negative 2x plus 3, state the domain, range, x and y intercepts. So your domain, negative 2x, has got to be greater than or equal to 0. So if I divide by negative 2, x is now less than or equal to 0. So that's my domain. Range is going to be y greater than or equal to 3. So x-intercept to y-intercept. So remember, x-intercept to y-intercept, that's where the other thing is 0. So for x-intercept, y equals 0. So what this is going to be, it's never going to cross the x-axis. Here's why. If I look, I've got a square root equaling a negative number. That's not possible. So there is no x-intercept. Y-intercept just ends up being what C is. Okay, my y-intercept is C. So C is going to be 3, so that's my y-intercept. Now if I sketch a graph, here's kind of what it looks like. It's going to look something like this. It's going to take off in that direction. The negative 2 flips it around. Plus 3, it goes like, this is what the graph looks like. Never going to touch the x-axis. And you can kind of sketch and see what that's going to look like. Now I encourage you, look at your chart, look at your graph, look at your table of values and see if that makes sense. So square root inequalities. Similar way, okay, equation is a boundary. Remember, this is going to be a dotted line. This is going to be a solid line. So y less than or equal to 2x minus 6. So you still want to figure out your boundaries. You still want to figure out your intercepts. So this is your domain. So 2x greater than or equal to 6. X has got to be greater than or equal to 3. So C is 0, so y is going to be equal to 0. So when I look at this, so I'm going to start at 3. It's going to be greater than 0. It's going to be a dotted line looking like this, like that. Okay, that's a dotted line. Then I got to figure out which way am I going to shade? Well, still, I'm going to test 0, 0. Is 0 less than the square root of 2 times 0 minus 6? Now, one problem with that. My point is not underneath the square root. So what I need to do is pick a point and then figure out inside the graph and see if that's true. So what I want to do is I want to take a point over here. I want to take an easy point. So that's 3. I'm going to take that one. That point is 4, 0. I'm going to put that in here and see what I get. Okay, so I'm going to put is 0 less than 2 times 4 minus 6. So 0 less than 8 minus 6. So is 0 less than the square root of 2? Yes. So that means I'm going to shade below this. So I'm going to shade everything right here. Okay, so that's what that one's going to look like. So if I go y greater than or equal to 1/2 x plus 2, so this is what I'm going to do. So again, find your domain. Domain, the part underneath is greater than or equal to 0. Okay, so 1/2 x greater than or equal to 0, so x is going to be greater than or equal to 0. The c part, y is going to be greater than or equal to 2. All right, so this is going to be kind of what this one looks like. So I'm starting kind of at 0, 2, and 1/2 basically means that it's going to be a little bit flatter. You can take, well, once again, use Desmos, use a graphing calculator, plot your points. You know, at 2 I'm at 3, at 0 I'm at 2, at 2 I'm at 3. Then it takes me all the way out to 8 to get up to 4. So it's going to be a very, very, very flat line. Solid line. So now I got to figure out which way do I shade. Well, here I'm going to pick a point and see if it's true. So now here I'll pick something easy. I'll pick 2, 0. I picked 2, 0 just because it looks easy and I can test it pretty easily. So if I go 0, let's test it. So is y greater than or equal to square root of 1/2 x plus 2? So is 0 greater than or equal to 1/2 times 2 plus 2? Is 0 greater than square root of 1 plus 2? Is 0 greater than 1 plus 2? Is 0 greater than 3? No, that's false. So that's false. That means I'm going to shade above it. I'm going to shade up there. So just these same rules that you've been going through since algebra, testing points, solid dotted line. It's just a different kind of graph. That's all I'm playing around with. So speed of a ball can be determined by this thing. Velocity equals 2k over m. K is your kinetic energy, joules. M is the mass of the ball. We're going to assume the mass of the ball is 5 kilograms. So we're going to go volume is going to be 2k over 5. All right, graph the function, state the domain and range. So your domain, 2k over 5 greater than or equal to 0. So k is greater than or equal to 0. There's no number underneath, so k greater than or equal to 0. Then your range, your y is going to be greater than or equal to 0. Consider that x, consider that y. All right, so that's going to be kind of what your graph looks like. So if the ball is traveling 6 meters per second, what is the ball's kinetic energy in joules? So if I set this thing equal to 6, okay, that's your velocity. How would I solve this? Well, I would square both sides first. So 2k over 5 equals 36. Then I'm going to multiply both sides by 5. That's going to equal 180. So 2k will equal 180. So k is going to be 90. That's going to be my answer. Okay, play around with this. Take your time. Use your graphing functions, either Desmos or a graphing calculator. Come talk to me with questions. And as always, don't be afraid to test a point.